particle projected vertically upwards from horizontal ground. So for part I, it's just going to be a standard Stuva type question. Constant acceleration. It's going upwards, so I can take upwards to be positive. Initial speed 8.4, so u is 8.4. Acceleration is minus 9.8 because it's the opposite direction. Greatest height, therefore the final velocity will be 0, and I want to find out what the greatest height is, so I got that. Formula is going to be one without the t, so that will be v squared equals u squared plus 2as. And substitute those in. 0 equals 8.4 squared minus 19.6 s, and so s equals 8.4 squared over 19.6, which equals 3.6 meters as given. Part 2, again this one's projected 2 meters above the ground, and the greatest height is also 3.6. so again this is going to be Stuva, constant acceleration. Again we're going to take upwards to be positive. U is what we've got to find out, so we'll put u as u. The final velocity is going to be 0 because that's going to be when it's at the top, minus 9.8. And the height it gets to, it starts at 2 meters above, and it goes up to 3.6. So I'm actually only going to try and find out how long it takes to get to 1.6. Yet again here it's going to be v equals u squared plus 2as. So substitute that all in there. 0 equals u squared minus 19.6 times by s, which is 1.6. That'll give me that u squared equals 31.36, and so u will equal 5.6 meters per second. Now we come on to part 3. And part 3 has got worth 6 marks. It's going to be quite tricky. Show that at the instant p and q are at the same height. So we've got p and q. So if this one's p, and q starts off higher, so q starts off right up here. So that's q, and this distance here is 2 meters. And we've got to find out when they're the same height. This one's going to go up, come down, and this one's just going to go up. They both end up getting to 3.6. So again, it's going to be a Stuva type thing. Let's split them up into p and q, and let's do the Stuva. D, u, v, a. And then we're going to have to put all the things we know in there. We're going to take upwards to be positive. The initial speed is 8.4 for p, and the initial speed, we just worked it out, is 5.6 for q. The acceleration, minus 9.8 for both of them. The velocity is what we're basically going to find out what the time is to start with. Find out the time, and then from that time we'll find out what the velocity is. So we'll find out when are they both exactly the same height. There's other ways, but this is the way I see it first. Okay, and we want to find out what the x is, or the height. Let's put down h. Find the height when they're the same. So we're going to have to use s equals the formula without the v. That would be ut plus a half at squared. We're going to use the same one over here. S equals ut plus a half at squared. And that will say that h equals 8.4t minus 4.9 t squared, and this will say that h equals 5.6 t minus 4.9 t squared. And we're going to say that when these are exactly the same height, but must remember these aren't exactly the same heights because this one starts higher. So we're going to say when it's a left-hand height, 8.4 t minus 4.9 t squared, that has got to equal the right-hand height, 5.6 t minus 4.9 t squared, plus 2, because the one on the right-hand side starts 2 meters higher, and we have to find the distance from the base. This will give me 4.9 minus 4.9 t squared and minus 4.9 t squared will disappear, and this will say that's 2.8 t equals 2, so t will equal 0.714285. Okay, and now we can find out the velocity. So for p, we've got the same as this. We're going to find the velocity, and v will equal u plus at. And for q, v will equal u plus at. And so that will, v will equal 8.4 minus 9.8 times the time we just worked out, 0.714, etc. And v will equal 1.4. And this one here, v will equal the original speed is 5.6 minus 9.8 times by what we just worked out, 0.714, etc. And that will equal minus 1.4. Therefore, different directions and same speed, obviously different velocities. So we've shown that they have the same speed and are moving in opposite directions, because one's positive and the other's negative. And that's question 5 done.